Hey Olivia, this is the whiteboards that we're doing today for geometry. We are just getting done with three-dimensional figures, so we'll have whiteboards today, and then we're going to do a mid-chapter quiz tomorrow. And so I told them you get to use your notes on mid-chapter quiz. When we get to the actual test, like at the end of the chapter, I will give you formulas for like these shapes, the three-dimensional shapes, but you will have to know the area, perimeter, circumference for like circles, triangles, squares, rectangles. Is that it? Yes, those four. Okay. So we're gonna do some whiteboard problems today. I'm going to hopefully not make you too dizzy here. Let's go to this guy right here. This is where I want to start. All right, I'm gonna ask you some questions. Are you ready? Just looking at this diagram. Okay. There's that diagram. I want you to name the sides of angle 4. List me the sides of angle 4. Angle 4. Name the sides. How do we name them? Naming the sides of angle 4. Get an answer and then we'll go through it. Okay? Name the sides of angle 4. Name the sides of angle 4. That's what I want. Okay? How many sides are there for angle 4? 2. C is the vertex, so it goes C to A. That's one side, right? And C to D, that's the other side. Those are the sides of my angle 4. Got it?
Oh, I
Perfect.
CA.
CA and CD, okay? Alright, let's do that again, but let's do angle 1. Name me the sides of angle 1. Now that you know what you're doing, name me the sides of angle 1. You see where angle 1 is? Up here at the top. Name me the sides. Sides of angle 1. Now that you know what you're doing.
Yeah, well, I did it right. So.
You gotta flip around though.
You start at
You always start at the vertex. Yep, your other one needs flipped around. Yep. Yep, you're good. Yep, you're good. Okay? Alright. Angle 1. His vertex is A, so both of the sides have to start with A. So AD and AC. Okay? It's gotta start with A. Got it? Alright. Give me another name for angle 1. Like using letters. Another name for angle 1. Angle something. Okay, give me another name for angle 1. There's a couple of them. 2 of them.
DAC.
Excuse me.
What?
Keep your answers to yourself, please. Oh, I thought we were saying them out loud.
Okay, one of you is not right. No. Both of you are not right. You are not quite right. That will work. I don't even know what yours says, Remington. Okay, angle 1 is this guy up here. I have to make sure that A, since he is the vertex, he is the middle letter.
Yes.
So it can either be CAD or DAC. Does that make sense? Yeah? If you said, I think somebody said like CDA, which angle is angle CDA? That's actually angle 3, right? Okay. Oh shoot, I should be recording this for Megan also. I just realized that. Sorry, I'll send this to you too, Megan. I forgot to say hi to her at the beginning. So, hi Megan. Okay, do you see why CDA is angle 3 and not angle 1? Okay, should we do another one of those? Name for me angle 2. What's another name for angle 2? Write it down. Another name for angle 2. Most people have ADE. You're just a crazy boy with your lowercase letters. You have to have uppercase. If you use lowercase letters, Remington, I will count them off. ADE. It has to be uppercase letters because points are capital letters. ADE or what else would work?
ADEA.
EDA.
Yeah.
EDA. Yep. Okay, now question.
No.
You guys can shout these answers out if you want to. Angle 3 and angle 2. What are those two special angles?
Linear.
Nope, they're not on linear pair. What are angle 2 and angle 3? Maybe. Well, if I put those little markings like this, they are congruent, yeah.
Vertical.
No, they're not vertical angles.
Horizontal. Is it the
Nope.
supplement thing?
Nope, because they're not supplementary. They don't add up to be 180. What are those two angles? They share a side, which means they are,
Corresponding.
Nope.
No, it's not corresponding?
It's not complementary.
Oh, they're
you wanna know what corresponding is, Luke?
What is, or no,
This one and this one are corresponding.
that's right.
Okay. What is angle 1 and angle, or angle 2 and angle 3? Starts with an A. Adjacent. You remember that? Those two angles are ADJACENT. Are they a linear pair? No, because the line or the angle that they make looks like this, okay? Do we have any linear pairs up here? Are there any linear pairs up there? There are, but they're not marked. So like angle 4, he has a linear pair with this angle right here, right? Like those two are a linear pair, but they're not marked, right? I don't think there's any of them that are exactly marked. Okay? Got it? Makes sense? Okay, let's go to like in this example right here. Nope, that's not the example that I want. What do these two little loops mean? They're congruent. They're the same measure, right? Okay? Alright, let's look at this guy. Let's say I say that this is 4x and this is 5x minus 10. This angle right here and this angle right here. Okay? What can you do to solve that?
You can
So
add them
for
up
X.
and make them equal to 90.
Are they equal to each other?
No, they're equal.
They might be, but we don't know that for sure, right? But we do know that they add up to be 90. How do we know that?
Because the
If this is 90, then this is the other 90, right? So we would say those two, and I don't think it comes out nicely.
No,
It doesn't come out nicely, I don't think.
X
unless you make it 5x.
What?
Make it 4x.
I make this 5x? Sure, let's do it. 5x and 5x minus 10. Okay, solve for x. Go. This guy's 5x, that guy's 5x minus 10. Okay, solve for x. 5x minus 10 plus 5x equals 90.
Yeah, you can't do that in your head. Subtract the 10 over.
Try to do
It's
it.
like,
And just divide
Did you get 10?
those. Or add.
For x?
Oh.
Did you get x equals 10? Yeah, yeah?
Oh my gosh.
Okay.
I subtract.
Alright, now, besides being adjacent, these two angles right here, what are they? They're adjacent, but what else are they? Starts with a C.
So,
They're complementary. I'm gonna write that over here. Complementary.
180 equals x.
Complementary angles versus supplementary. Okay, what's complementary mean?
90.
They add up to be 90, right? This morning Aiden said less than 90, and I was like, you're thinking acute. Acute angles are is one angle that's less than 90, right? Supplementary means two angles that add up to be 180, okay? What is it if it's greater than 90 and less than 180, one angle? Obtuse, right? So don't get obtuse and acute confused with complementary, supplementary. Complementary, supplementary are adding angles together to make 90 and adding them together to make exactly 180. Got it? Okay? Supplementary. We have like linear pairs right here, like these two angles making a straight line. How would you find this guy? Like, how would you find this angle?
180 minus 50.
180 minus 58. I think you actually had to do that one for your homework assignment, I think. But linear pair. Are linear pairs always supplementary? Supplementary means they add up to be 180. Do linear pairs, if you have two angles on a straight line, do they always add up to be 180?
Yes.
So are they always supplementary? Yeah. Yeah, they always are. Okay? Good? Alright, let's go to the next one. Let's do, I want you to do this one right here. Solve for x, solve for y. Holy crap, holy.
I don't know.
You know where to start? We got x's and y's going on. I have like x's up here and I have like y's over here. What do we know about these two angles?
They're supplementary.
They're supplementary. They add up to be 180, but I can't solve for x and y at the same time. Boo.
those two would also be supplementary, right?
They are supplementary?
The 3x minus 10.
This one and this one, do those guys add up to be 180?
Yeah.
No, they equal.
They equal each other. Why do they equal each other? These two angles. Why do those two angles equal each other?
Because they're
They are, what's the name for them? When they're across from each other.
Isn't that the line though?
What?
Or the angle? Never mind.
Yeah, you're talking about angles.
I'm going
Um,
straight.
What are those two called? No, your X is right, but your Y is not.
They're the same, right?
How do you know they're the same? What are they called?
Vertical.
Vertical angles.
No way.
When they're across from each other, they're vertical angles. Vertical angles across from each other. Alright. Solve for X. Go. Solve for X. I will do that as well. You said they're equal? Because they're vertical angles? Okay. Solve for X. You betcha. Then we're gonna solve for Y. Your Y is not right still. Oh, wait. I can't see.
85.
85. Okay, I thought it said 55 still.
Can you
Is
read
that
that?
right?
No, I can't
Is
because I'm
90 plus
blind.
85 right? No.
85
It's
is right.
35.
35 is X, right?
Is it
Yeah.
35
Okay.
and 85?
Oh.
So,
Is
No.
Y 90?
ah,
X is
erase.
35.
Okay, X is 35, right? So we got 35 as an answer, and then this morning to figure out what Y was, somebody said, let's subtract that from 180. Not quite. What do you have to do first? We have to plug 35 in. What's 2 times 35?
It's 90.
70 plus 25 is 95. So this guy's 95, this guy's 95. So then subtract that from 180, and what's Y? Somebody had it. 85? Y is 85 degrees. Got it? Okay. Good. Alright, let's go to, let's go on down to, do you guys want to attempt this one, 36? Did you have to do that one for homework? I don't think so. Okay, let's do this one. We got lots of stuff going on here. 2 of the angles aren't labeled, but the rest of them are. 114 is this guy. This small little guy right here is 2y. This guy right here is 3x minus 24, and then this is 5x plus 4. What are you gonna start with? Anybody got any ideas? Huh?
So can we do a
Can we set 5x plus 4 equal to 114? Are they the same? Here's my straight line here, and here's my straight line here. Are those two the same? They're vertical angles? Yes, that's exactly where I would start. Okay, solve for x. Okay, you guys do it. Solve for x. I got the 22. X is 22. Yep. Okay, let's plug x back into everywhere he is. So 22, 22. Got it. Okay. This guy's gonna be 114. 3 times 22 minus 24. Does somebody have that? 66 minus 24. 42. 42. Okay. So this angle's 114. This angle's 42. And now we have to figure out what y is. How the heck do you do that?
So do we
Add
those and then put
114.
them in?
Add 114 and 42 and subtract that from 1.
So yeah, this is a straight line, so that means all 3 of these angles are gonna be 180, right?
156.
Okay. So if this is 42 and this is 114, that's 156, you said. 180 minus 156 is 24. So this angle right here is 24, so what's y gonna be? 12. You see how that works? Woo! That's a lot of like running around for that problem. Okay, got it? Okay, we get out at, we got 15 minutes, okay. Let's go to complementary, supplementary, we already talked about those. Do you want some more complementary, supplementary questions?
Sure.
Sure? Let's see what we got. Maybe somebody busy. Okay, let's do this. Looking at this diagram, do you guys see him? false? 6 and 8 are complementary angles. 6 and 8. What does it mean to be complementary?
Is. They make 90.
They make 90. Do 6 and 8 make 90?
Yes.
How do you know that?
Because angle 7 is 90.
This is 180. This is 90, so this would be the other 90. So 6 and 8, do they add up to 90? For sure. Are 6 and 8 congruent to each other? Is angle 6 congruent? Whoop, congruent. Not congruent. Congruent to, oh heavens to Betsy. Congruent to angle 8. True or false?
True.
Are 6 and 8 the same?
We don't know.
We don't know that necessarily, so yeah, we don't have enough information. Okay, what about angle 2 and angle 4? Is angle 2 congruent to angle 4? How do you know? 2 and 4, you're right. 2 and 4 are the same. What are those called? What are 2 and 4?
Vertical.
Vertical angles. Okay, give me another pair of vertical angles. 7 and 9 is another good one. Yep. Anything else that's labeled? Is 3 and 5 vertical angles? No. Okay. Alright. I've exhausted that, I think. Okay. Let's go to another one. Alright. Let's go to this one. Let's go to here. Here we go. Okay, alright. Circumference and area of a circle. Do you remember the formulas for it? Tomorrow you'll have your notes so you can look it up. But you need to get into the habit of memorizing them. Anybody got the circumference and area formula? Or one of them? For a circle. What? Pi r squared. Which one's pi r squared? Circumference or area? Pi r squared. Area. Pi r squared. And then 2 pi r is the other one. Right? Pi r squared, 2 pi r. They all involve the same little pieces. It's just one of them squared and the other one's just out in front with the 2. Okay? Alright, how do I find the circumference and area of this thing? What do you have to do first? Find the radius. Find the radius. Okay, so how do I find the radius of that thing? You're gonna have some distance formula tomorrow. You'll have a couple distance formulas. Okay? Alright, how do I figure out what goes in the first little bubble?
It's like 58.
Negative 3 and 0?
58.
How far is it?
3.
3? How far is 1 and negative 6? 7. 9 and 49 makes 58, which is 7 point, I don't know. 7.8? So let me take the square root of what?
I don't know. I'm just saying numbers.
Square root of 58. What you got?
7.6.
62. 7.6 is my radius. Okay, 7.6. Alright, now you calculate the circumference. The radius is 7.6. Figure out circumference and figure out area. Go. We'll check them here in a second.
Ew.
Circumference and area.
Isn't it the diameter? Circumference is yeah. But it's not just the radius.
What? On circumference?
Yeah. Isn't it the diameter?
So you can either do 2 pi r or you can do diameter times pi. Because 2 times the radius is the diameter. Does that make sense? Yeah. So either way you want to look at it. You can either double the 7.6 or use 2 pi r. I got 47.8
Yep.
and I got 181.5. Cool? Good? Okay? Can you do that problem by yourself, start to finish, with the distance formula and everything? Sure hope so. Let's do, I don't know what else we should do. Should we do a triangle? Okay, let's do this one. I'm gonna make this one up. a right triangle. Okay, find the perimeter and find the area of that triangle. Perimeter and area of that one. Perimeter and area. Did you get an answer? You have to do the Pythagorean theorem to find the third side. So 12 squared plus 9 squared equals c squared. 144 plus 81. And you should get something like 15.
Yep.
Yeah? Perfect. Because that is a 3, 4, 5 right triangle. Did you know that?
Don't you know?
Sure. 15. Oh, we'll learn those in this class. Perimeter then would be 24 plus 12, so 36. Did you get 36 for the perimeter?
Yep.
Units, whatever, just units. Area. 12 times 9 divided by 2. What?
I was 54.
54. Units squared. Okay? Good? Happy with that? Alright, let's go to something else. What time we get out of here? Okay, we got one more thing that I really want to hit on. I'm making whoever dizzy. Don't look at the screen. I'm making you dizzy. Okay, here we go.
Where did my eraser go?
Alright. Okay, we have 3, -4 is the coordinate point that I want. And we're gonna take him and we're gonna reflect him over the x. We're gonna go over the y. We're gonna go left 3 and up 6. We're gonna go a 90-degree rotation. We're gonna go a 180-degree rotation. And we're gonna go do a 270 rotation. Okay, but we're gonna write the rules out first. Okay? Those 6 things is what we're gonna do. Can you see? 3, -4 is my starting point. Okay, let's write the rules out together. See if you can remember any of these. Okay? If you go over the x-axis, how do the coordinate points change? Do you remember?
X becomes negative.
Nope.
No, Y becomes
Y becomes negative, the opposite one. So it stays x, y. X, negative, y. So what happens to that coordinate point?
It's 3, 4.
It's 3, +4, right? Okay, over the y-axis, what changes? X becomes negative, okay? So 3, -4 becomes what? -3, -4, got it. Okay, now, if you're going left 3 and up 6, they put it in like these triangle brackets right here. Left 3, up 6, what numbers go in that triangle bracket thing? What? 0, 2 will be the answer, yeah. So 0, 2 is what the answer will be, but what goes in the triangle brackets?
+3.
-3. Left is minus. It's not like algebra where you do the opposite. That's in the formula. And up 6 would be 6. So this triangle bracket thing, that tells you how you're moving it. So left 3, up 6, that's what it'll look like, okay? If you combine these two, then it gives you 0, 2, right? Got it? Remington, what are you guys doing over there? Alright. 90, 180, 270. You guys remember the rules for these? I always think 90 and 270 are the same. 90, 270, you flip them. But then you do one other thing. What else do you do? 90 and 270, you flip them. Y and X, you flip places.
One of them becomes negative.
Which one becomes negative and 90? Like, it's kind of hard. Like, where the X was originally, right? The first one becomes negative on 90. The second one becomes negative on 270. Why? Because 90 comes before 270, right? That's how I remember that. So they flip, but the first one and then the second one. Okay, what about 180 rotate? What's the rule for that one? They both just flip, so it's negative X, negative Y. Because a 180 rotate is like going over the X axis and over the Y axis, right? You're just reflecting twice. So you're making the two negative. All right, so if we start with 3, negative 4, and you go 90 rotate, what does he look like? 4, 3. What about 180 rotate? Negative 3, 4. And the other one? Negative 4, negative 3. Okay, all right. I want you to do the same thing again, but with the point negative 2, 9. Except I'm gonna give you this. Do these real quick. Okay, and then we'll check, and then we'll be done. Okay, negative 2, 9. I want you to go over X, over Y, right 2, down 7, 90 and 180 and 270 rotate. Write the rules for what those guys are. Okay, write out what you get. We'll go over it and we'll be done. Did you get an answer? Should we go through them? Okay, over X, I got negative 2, negative 9. Yeah? Over Y, positive 2, positive 9. Right 2, down 7, 0, 2. Was that the same answer as what we got before? 0, 2?
No.
I don't remember.
Yeah,
Yes,
it
it was. Okay. 90-degree rotate. Okay, flip. 9, negative 2, but the first one becomes negative. 270 rotate. 9, negative 2, but the second one becomes negative. So 9, positive 2. 180 would be positive 2, negative 9. Yeah? Beautiful. There you go. Okay? Alright, make sure you get your notes and everything ready to go. We'll check the quiz tomorrow. And then we'll move on. Okay. Alright, goodbye whoever's watching this video. Megan and Olivia.